Hello everyone. Hope everyone is having a great weekend so far. This is going to be hopefully the last video for Introduction to Data Science, Science 1. I'm quickly going to go through the slides for week 6. I'm going to do some of the coding that we didn't do during the class. And just to make sure that everyone is able to run all of the codes, especially for the web scraper in R, which not everyone did run it, and because it dependent on whether you were using a Windows machine or a Mac machine. But anyhow, we're gonna go through the slides again to make sure that everything works perfectly. Well, the first part was about clustering, which we talked about what clustering is, and we talked about this example, this iris dataset, for example, which if you plot the sepal length and the petal length in this example, you can add the species as a color, you can see like 3 separate classes, right? Not exactly separate. I mean, here there's a mixture of blue and green on the border, but that's how it works. I mean, there's classes are never disjoint from each other exactly. They usually overlap. Now, in clustering, well, the problem is we just want to do the same thing as classification, but without having the species, for example, and we just want to figure out like what are those 3 separate clusters from each other. And then so the algorithm that is used for doing this is called clustering, and these are the 4 useful methods, and we're going to talk about K-means, how K-means work. So we went through this algorithm, if you remember, K-means, these all different steps that will converge to different and separated clusters with centroids for each of the clusters. And then in K-means, we also have to define the K, what the K is, like how many clusters do we have. In our example, K is 3. Well, how do we figure that out? Well, one way was to ask an expert to tell us that, okay, it looks like, I mean, according to this data set, there should be like not more than 3 species. And also, a lot of times there's not much difference if you increase the number of clusters. It's because it's just going to be like the same cluster is going to be splitted into multiple clusters, and you can still concatenate them together. You can combine them together. But here, for example, there's a big difference between 1 cluster and 2 cluster, because if you pick 1 cluster, it means like all of these data points are going to fall into 1 cluster. But if you pick like 2, this is definitely going to be like a separate cluster here. You can see like it's so different from the rest of the data points here. Yeah, and that's how it works. Now, all right. Now, let's go through the clustering in R and see how it works. Well, this is some code. I'm just going to do this coding in R Studio so you can see how it works. And well, the question is that we want to pick these 2 columns, the sepal length and the petal length, which is the first and third column of the iris dataset, and then we just want to do the clustering. We want to cluster it using K-means with K equal to 3. I'm just going to go here and open R, and inside R, I'm going to create a new R script. So this is for, let's say, week 6, the video. I'm going to put up all of my codes here. If you need, I can send out this code to anyone. So let's do the K-means clustering in this example. And well, it's under the stats library, so I'm first just gonna I'm going to load this stats library, and in the next step, let's look into what the iris dataset is one more time. If I run these 2 lines of code, right, here's the iris dataset. We want to pick the sepal length and the petal length, these 2 columns, and in order to cluster them based on K-means. And this is how it works. For example, we're going to say that, okay, there are clustering, or let's say I'm going to use the same names that we have in the slides. Iris clusters is going to be K-means. See, here's the method, and the input for the first input of the K-means is going to be the data set that you want. and because we're just going to be including the first and the third column, that's why I put C of 1 and 3. And the second input of k-means is basically the number of k, the value of k. In this example, we're going to pick 3. Okay. All right. Let's run this line of code and see if it works. It did. Now, iris clusters is generated here as a list, and it has a bunch of variables, and which, for example, one of them, if you put a dollar sign, you can see all of the the features and the variables that are included in iris clusters. And for example, the iris clusters dollar cluster, if you run it, you're going to see like the labels, the number of clusters for all of the elements in iris. In iris, we have 150 objects, right? 150 rows, 150 flowers. And here you can see we have 150 numbers, and each number is indicating the number of the cluster. Now, the number here is not important at all. One of the students sent an email yesterday asking about these numbers. I mean, it doesn't really matter if the first cluster is 1 or 2 or 3. It doesn't matter. The only thing in clustering, the only important fact in clustering is that we just want to find like the data points that fall together in one single cluster. Now, it doesn't matter if these objects are 1 or 2 or 3. It's just like important that they should be the same number, the same cluster. That's what we're looking for in clustering, right? Because these numbers really don't have any specific meaning. All right, and iris clusters, even if you print out this whole list, it's going to give you some information about your clustering. And I remember like one of the students asked this question during the class, that how can we find the centroid points? Well, here they are. For example, these 3 clusters, it's giving us a kind of like a summary of the characteristics of the 3 separate clusters. For example, the first cluster, the sepal length is this, the petal length is this. It's like the average, right? It's like the centroid point of this cluster number 1. The number 2 is this one, the number 3 is this one, and so and if we have more clusters, we're just going to get that information. And then these are the clustering vectors as well, which shows what are the clustering numbers and some other information you can find here. All right, now one thing we did here in the slides was just using these cluster numbers in order to give a label, give a color to them, right? Without using the species, we're just assuming that we don't really know what the species are in the iris data set, even though the last column is the species, but we're just ignoring it right now. Now, what I'm going to do is I'm going to add a column, a new column, so I can create like a cluster column, and which is going to be the iris clusters dollar cluster. Now this is going to add these clusters that we made through k-means to it's going to add it as a separate column to the iris dataset under cluster. Now let's do this. I'm going to run this line of code and then look into iris, and you can see that like the last column is added called cluster, and you can see 1, 2, 3 are the labels given here. Now if you want to, so here we can actually do the ggplot, a scatter plot of, okay, before getting into ggplot, make sure that you load the library ggplot, otherwise it's going to give you an error. All right, I'm going to load this one, and then Stack Overflow is a great place to get help. Interesting. This is the first time I'm seeing this. It's like a new message sent out by ggplot2. It's really interesting. It's like kind of advertising Stack Overflow here. Anyway, this is probably maybe ggplot got updated here. It's the latest version that is printing this out. I've never seen this before. But all right, let's do a scatter plot here for the iris dataset, including cluster labels. So I'm just going to add like colors for this different clusters. So it's a ggplot of the iris dataset, and the columns that we want to add is the x and y is actually the sepal. What is it called? So the x, let's say the x is going to be sepal.length. So sepal.length. Let's do the same as here. Yeah, sepal.length, and then that one is petal. The y-axis is going to be the petal.length. We are also going to add a color for the cluster column, and then here plus genome underline point. It's going to give us basically a kind of scatter plot. Now here it is. Now the reason that we have like you can see like a spectra of colors, and it's not exactly like distinct, like discrete colors like here, like blue, green, and red, is because the cluster column is numerical. We have to convert it to categorical if you want to see discrete colors. So you can easily change this to as the character of cluster, probably, and then do this, and you're gonna see like the same thing that we have in the slides, the same colors. Now you can even change the size. I think like the size of the data points are pretty small, and change it to 5. Here we get like bigger dots as well. All right, the same figure. So this is how you can basically do clustering under K-means. We talked about supervised and unsupervised learning. So supervised was all of the algorithms, which basically the data has labels like classification, prediction, regression. But unsupervised learning is any sort of algorithm that doesn't have any labels. For example, clustering, and you want to figure out what the labels are and what are the data points that fall into together. All right, associational mining. Well, we talked about this during the class. I'm just going to skip it for now. You can go through here, and then I just put up a link here. And there's a step-by-step tutorial which you can go through and run associational mining on the Titanic dataset and get these results as shown here. All right, let's get to the next part. Web scraping and R. Yeah, this is probably the part that I just want to give more explanation for you. Well, the first part for setting up the Selenium web server on your computer, I found a very easy way to do this. I mean, there's no need for, we can skip some of these steps. Now, before getting to this, let's open the file that I sent you under the week 6 material folder. Let me see where it is. It's should be somewhere here. Let me see. Oh, it's in desktop. Okay. And then week 6 material. There's an R file called webscraping.r. If you can look this up. Just going to remove this. You don't have this here. I'll add it myself later. Now, well, okay, you can see this code, right? The symbol code which was able to navigate through R. Now, the whole point here is like how to set up the how to set up the Selenium server, the jar file on your computer. Now, let's go here. No matter what, if you're using a Windows or a Mac machine, we're going to do this. Doesn't matter. Now, well, the first thing is that you have to make sure that you have Java installed on your computer. This is the first thing. So you can, search for Java, either for Mac or Windows, and make sure that you have it installed, because we have a jar file that has to be compiled under Java. Now, the second step, download the Selenium standalone jar file. Forget about this, guys, okay? I'm just going to remove this from the slides. You don't need to do this. We're going to write a script which will automatically do this for you, okay? Now, the next step is install and load our Selenium in R. Yes, we need to do this. So let's first do this. First, make sure that you have R Selenium installed. You can go here to packages, install, and then R Selenium. R Selenium, here it is. And then install. After you install it, you can write library R Selenium and just load this function. These are like 3 sub-libraries under R Selenium. Now, after doing this, I'm just going to add another step. Alright, and then the next step, copy the jar file. Well, you can remove this as well because we don't have any jar files at this point. Just remove it and remove this one too. You can skip it. No need. Alright, before getting to run the webscraping.r file, which will start navigating through a website, I'm just going to add a single step here, which is run the code, this code here. It's called, so it's under R Selenium, and it's R Selenium, similar to here, R Selenium start server, which we put like 2 colons. We're going to put, this means like, this means that it's a function that exists in R Selenium. So if you load R Selenium, you don't really need to write this part. But anyway, just for to be on the safe side, we always write we can write the name of the library and then put 2 colons, and it's gonna give you access to all of the built-in functions in that library. For example, our Selenium, and then it's start server, I guess. Not, I'm sorry. Well, start server is this, right? There's a function called, I'm just gonna write it here. Let me write it here, and then I'm gonna add it to the slides. It's so before getting to start server, we have to install our Selenium, the Selenium server standalone jar file on our computer. There's one function for doing this, our Selenium, and then it's called check for server. That's simple. This function is going to, so you only need to run this only once, okay? You don't really need to put it in your script. You can run this only once. What it's going to do is going to go and download the latest version of the jar file and automatically copy and put it into the R Selenium directory, library, wherever R is installed, okay? It's going to do it automatically no matter if you're using a Mac or Windows. This is very cool. It's going to make it super simple. So I'm just going to add this to the check for server, right? Here to the slides. Okay, so check for, what was it? Check for server. Now this is going to basically download the latest jar file for Selenium and put it into the R Selenium folder library wherever R is installed on your machine. This is really cool, isn't it? Like, okay, I'm gonna do it. For example, I don't really have I don't have the jar. I just removed the jar file that I had on my laptop. Let's run this line of code and see what happens. See, so downloading the standalone server of Selenium. It's gonna take a few minutes. It's downloading the latest version. Basically, see, it's like version 3 is the latest version of the Selenium standalone. It's 21 megabytes, and it will download it. It did the download. It's just giving a warning message. You can ignore it. It's okay. And it's what it did was download the file, copy and pasted it into the R Selenium folder where the library is installed on your computer. All right. So you just have to run this only once. Okay. I can remove it here from my script for next time, and you don't really need to run it anymore. Now let's get into the R script code. Well, the rest of the code is exactly the same as we ran during the class. I'm just going to go through it really quick. Oh, the first step is to start the server. You have to run that Selenium standalone jar file on your computer, so it's running now. Now here I just create a new remote driver, and then these lines of code is going to open a browser for us, so you can change the Safari to Chrome or any other browser that you like. For example, you probably don't have Safari on Windows, but you can put like Chrome or anything you want on, or you can put Firefox, and it's going to open a Firefox window for you. I'm going to run this line of code and see what happens. It's going to assign this browser to remote driver, and after you run this function open on rem driver, it's going to open the browser. See, it's going to open the browser. All right, so this browser is basically this directory, remote driver is pointing out to this browser now. Whatever we do, any sort of navigation we do on the rem driver is going to be applied on the browser, as you can see right now. All right, I'm just going to go through the rest of the code. It's pretty simple. I'm going to navigate to, so I'm going to run this line of code, line 20. I'm going to navigate to google.com, and then here, if you run this line of code, it's going to give you the current URL that you're pointing at, which is google.com. You can see here, and then in order to access the elements in the DOM on the HTML browser, you can run this line of code. It's going to what this is going to do is it's going to access this text box here. How did we find the ID of this? Well, in this example, I just right-click here and then inspect the element. Well, if you're in Windows, you have to look into the source code, and then if you go into your code, you will basically find. Let me see where it is. Here it is. So here's the ID of this text box. It's lst-ib, and I put it here, lst-ib. So this function here, find element under remote driver, is going to find the element in the HTML code, which has an ID of lst-ib, and the IDs of all of the components on any browser, on any website, is definitely unique, right? We don't have two objects that have the same ID. Now, all right. So using this ID here, we're going to access this, right? Okay, so when I run this line of code, line number 25, what happens is that this web element is going to be pointing out to this text box here. Now, in the next part, I'm going to use a function called send keys to element in order to write and send some text into this text box, because this web element is pointing out to the text box here in google.com. If I run this, it's going to type how old is Obama into the text box. Now in the next line, what I'm going to do is, what I have to do is in google.com, well, you can go to the website here and just make it a little bigger. Now the next part is going to be clicking this button, right? In order to click this button, you can right click on it and inspect the element to see what the class is or the ID is, right? So the class is SBICO, or I'm using the name actually. So here the name for that button is BTNG, right? So BTNG with a capital G, here it is. I'm using this function find element again, that is under the remote driver, in order to find an element, an DOM, an object in my HTML code, which the name is BTNG. Now this web element is going to be pointing out to this. So if I do this, what happens is it finds that button here on the right hand side on google.com, and then when I apply click element, it's going to search for that text that I have in google.com. Now you can just play around with this. You can now go to different links. You can go to any of these tabs. You can just any navigation you want to do. I mean, you can just right click on them and then inspect element and see what their class or their name or their ID is. Put it here and find them out, and you can do anything, right? You can just easily customize this. You can do a lot of more complicated tasks. So let me just run this one more time from scratch. If I run these lines of code, see what happens. It's going to go to google.com and then type in how old is Obama, and then it's going to press. It's going to press the search button. All right, now this is how it works. Hopefully everyone can get this running on their computer. I mean, if you have any questions, let me know, please. Even if it's Windows or if it's a Mac machine, it should work. All right, let's go to the next step and the next part. Now, the next part is the lab work. I mean, I hope you've done it yourself, but I'm just going to go through this to make sure that everyone can get this working. All right, so the lab work was about the spam data set that we had in week 5. I included it into the week 6 material folder. You can access the data there, the headers and everything. Now let's look into the data one more time just to make sure that you remember what the problem was. Now here inside this folder spam model, there's one spambase.csv file. If you open it and look at it, this is the raw data that we have. Now there's like probably a couple hundred or maybe 1,000 rows, and every row is pointing to one single email. Now in every email, so every row is one email. Let's look at the first row. These are a bunch of numbers, a frequency of sum of words that exist in the email, right? In the email. And finally, the last column is going to show that if that email is considered as a spam or not. If it's 1, it shows it's spam. If it's 0, it's non-spam. Now, there's another file called spambase.headers, spambase headers, which exactly introduces all of those columns and tells you what they are. So, for example, here, like the first column in this spambase, here it is, like the first column here, this first column in the spambase dataset.csv is the frequency of the word make, right? And it's the frequency of the word make. Now, how is the frequency calculated? Well, it will count how many how many times the word make occurred in the email, and then divided by the total number of words in the email, multiplied by 100. That's how you get the frequency. Or like the second one, let's look at it. It's 0.6. What is that? Well, the second one is the frequency of the word address. So in this first email here, in this first row, there's a 0.64 frequency of the word address inside the email. How it's calculated is going to look into how many times address occurs inside this email, and then it's going to divide it by the total number of words, multiply by 100. It's going to give you the frequency of the word address. That's how it works, and so forth, right? So there's like a bunch of words frequencies, and then there's a bunch of frequency of some punctuations, as you can see, like semicolon and parentheses and bracket and so forth. And there's also like 3 other features that are about the run I'm sorry, it's about like the capital letters, like how many capital letters we have in total, and what is the average length of capital letters that are consequent with no interruption, and so forth. You can find the explanation all here in this header data set. Anyway, so here these number of columns, these number of features should be exactly the same as the number of columns we have here minus 1. So it means like we have like 57 features here, and then we just have the last column as the spam or non-spam. So we're going to use all 57 features, let's say, without using feature selection at this point, and we're going to use all 57 features in order to classify column number 58 based on whether it's a spam or a non-spam. Now, in order to do this was the lab work for week 5. I'm just going to write the code because we need it in order to do the lab work for week 6. Now, in order to do this, you can go through this folder, spam model, and then open up the spam script. Well, before getting to that, I'm just going to, all right, well, let's first navigate to this folder, and then because we want to read, some of these spam-based.csv and the spam-based header file. So when you navigate to this folder, make sure that you set it as a working directory, so we can access this data here. Now, all right. Before getting to the lab work for week 6, I'm first going to write a script in order to build a classification model for classifying spam or non-spam. I'm going to create a new one. So this is the spam model, and what I'm going to do here is basically, well, first of all, I'm going to use a library called well, before that, let's first read the spam data. So the spam data is it's a CSV file of spam base.csv. That's what I think I renamed this file from what it was originally. And then here we have to define whether the header should be true, and then one else, string. We always put string as factors as false, so it's just going to read the raw data. And I'm going to run this line of code, and then you can look into spam data set, for example, this spam data that we created here. It has 4,600 rows, and then 58 objects, which 57 of them are the features that we want to use for the classification model, and the last one is the target variable that we want to classify, which is the spam or non-spam. Now, if you can look at here, I mean, the names of these columns really don't make sense. I mean, they're like something random because we didn't have any column names in the spam-base.csv file, but we don't care. We just know like what these are exactly. I mean, the names are not really important at all. They're not useful. Okay. Now, we just need this data. We just need these numbers. Now, how this works is, let's get into first creating a training set, and which is going to be the spam data well, we're going to be picking all of the columns, so I'm going to leave this one blank, the second index, but the first index is going to be the rows that we want. As you remember, we can use the sequence, start from 1, end at the number of rows that we have, and rows of spam data, and jump by or skip by, let's say 3, right? It's okay. I mean, we're going to be counting 3s. We're going to be skip counting by 3. In order to make sure that we have randomly selected rows, and you can put 2, 3, whatever, anything you can put here. I'm just gonna pick like a smaller data set. I put 3 so that this training data set is gonna be smaller, so we can run it faster. Now let's see what this training is. I'm gonna run this training. Well, this is the training data set, which is like a slice of the spam data set. Now, the next part is to run a model on this, right? We want to build let's say a nearest neighbor classifier on this training model. So first, before getting to this, we need to load the library caret. If you don't have it, you need to install it. So I'm going to load it. It's loading the package here, and then I'm going to create a model, which using the train function inside the caret package, and I'm just going to put the name of the last column. So we have to look into the training set. What is the name of the last column, which is the spam or non-spam? It's called x1, right? So I have to put, you can change the name of that column if you want, but it doesn't really matter. You can just put x1 here, and then you put the tilde dot. Remember, this is the syntax. And then what is the data that you want to use to train? It's called training. And what is the method that you want to use? In this example, we want to use k nearest neighbor. So it's called kknn inside the R package. I'm going to run this line of code. It's probably going to take a few seconds to run. Well, and after we train the model, usually what we did in all of the examples was like and then we applied it on a train set, and then I'm sorry, on a test set, and then in order to measure the performance of the model. But that's used for, in all of most of the cases, whenever we split the data to do that, it's because we just want to measure the performance of that model. And for example, we want to compare different models, different classifiers with each other. For example, k nearest neighbor versus random forest versus SVM, and then pick the best one, right? That's what we didn't do. But at this point, for the lab work for week 6, we really don't want to do that. I mean, because we don't need to do that, because let's go through the lab work. I'm just going to tell you why. Now, okay, so the rest of the lab work is, well, we first did this because we built a model on the train set of the spam data set. Well, it's telling you to do the random forest, but random forest is going to take longer. So you can put RF instead of KK and N as the method, and just do it for random forest. You can pick a smaller data set for training to do this, because it's going to take a lot of time, pretty much, to run with random forest. Random forest is definitely slower than k nearest neighbor, much slower. Now, but anyway, let's say instead of random forest, we just take the k nearest neighbor for now. Now, let's say if you want to like see what the performance is, you can also test it. I mean, let's do this because this was the lab work for week 5, which is let's define a testing data set in order to. So here we just want to, let's say, measure the performance, or let's say evaluate our classifier, or the spam classifier. Evaluate the spam classifier, and in order to do this, we're going to define something called testing. It's going to be the spam data set and all of the columns, but instead of the sequence, we're going to pick the sequences starting from 2 and row of spam data, and we can skip by 3, for example. We're going to run this line of code, and then we can after this, let's say the predicted spams are going to be predict and then apply the model that we built on the testing data set. Let's see if it works or not. It does. So the predicted spam is going to be like a bunch of 0 and 1s, telling us that if telling us what the spam class is for all of the elements inside the testing data set. Now let's calculate the accuracy. So the accuracy is going to be, we have to check like, okay, how many predicted spam are exactly the same as testing of x1, right, which was the last column, I guess. Let's look into testing. The last column should be x1, I guess, right? Yeah, it is. All right, so test 1, how many are the same? So I'm going to put a sum. This is going to be a bunch of true and falses. I'm just going to sum it up and then divide this whole so I'm going to put it again in parentheses and divide it by the number of rows, which is like the number of emails that we have in the testing data set. If I run this line of code, let's see what happens. Let's see what accuracy is. It should be something low. See, 45. It's like 45%. Why is it low? Well, it's because of we made a mistake here. We made a mistake. Yeah, it's something that during the class I mentioned that I didn't get many emails about this. But the problem is because this is a classification problem, right? Here, when we train the model, what we're doing is we're training this model, this nearest neighbor, on this training set for which column? For the last column. Now, in classification, the value that you classify should be categorical. It should be. Otherwise, it's going to be considered as regression. And that's not what we're looking for. We are looking to predict either 1 or 0. When you put numbers 1 and 0 here, which like this case as numeric, the point is that the model will think that this is a regression problem. So it will start making some prediction for these 1 and 0s, but not exactly 1 and 0. It will start making predictions for based on any values, any numbers that could be between 0 and 1, or even larger or smaller, right? For example, it's going to predict like this row as like 0.9, not 1. That's the reason that we got a 45% accuracy here, because it means that it did a regression, and then when it was measuring the accuracy, only 45% of the outputs on the test set were exactly 1 or 0. The rest are probably some numbers between, like 0.5, 0.6, 0.7, 1.1, whatever, anything around that. Now, to make this categorical with only 2 categories, we have to go back here to our data, and then here for the training data, before we feed it into the model, before we pass it to the model, we just have to make sure that the last column is going to be a character. So for the training, $x1, which is the last column, is going to be, should be, either you can write as.character or you can write as.factor. It's both the same thing. It's just going to like categorize the data. So the training $x1, let's run this and then do the modeling on this data set and see if it changes or not. If the output changes or not, if the accuracy changes. Let's see. Well, I think even before this, when we were running the model, it was giving us a warning, I think, on this example, on this case, that this is like you're using like a classification model, but you're applying it on numerical values, because k-nearest neighbors is a classification model. Anyway, but here we converted to a character just to make sure that it's that the last column, spam or non-spam, is a bunch of categories, 0 and 1s. And then here we trained the model, which finished training the model. And then here we have the spam data set. So here again, we have to just make sure that the testing data set also has the last, well, we don't really need it here, because I'll tell you why. Now here the predicted spam, let's do this one this time, right? And for the accuracy, it's going to be like the sum of predicted spam equal to testing of x1. Well, we have to put as.character here again. Well, I think I made it a little complicated. We could, even before getting to train and test, I mean here, we could just create the last column of spam data into a character, just to make sure that whenever we use that last column, it's always categorical. Spam data $x1. I'm going to do this one. All right, this one, so you don't really need to do this anymore, the training. All right, let me run this code again, build the model, and then after the model is built, we're going to apply the model on the testing data set to see what the classes are, whether they're spam or non-spam. They're predicted as spam or non-spam. It's the next step. Now, just waiting for the model to run. It's going to take a while. All right, now that this, I'm going to run this line of code, testing, and then predict the model versus testing, and calculate the accuracy. Let's see what the accuracy is. Now it's 90%. Now this makes sense. I'm sure if you use random forest, it's going to be around like 95 maybe. Well, it depends how you split your data for sure, but it's usually higher than k-nearest neighbor. It's like one of the most accurate methods, you know, in general, not always. Now, this is 90% accuracy we have here. We got. Now, the problem for this lab work is that we want to apply this model on some real emails, okay? On some real emails that you have. In other words, we just want to build a model using this trained data that we had here. For example, this model is built right now, okay? And we just want to apply this model onto a real data set, onto a real email, and see whether that is going to be classified as spam or not spam. That's what this lab work is. You can go through the details in the slides. I've put it up there. Now, the next thing is that we don't really necessarily need to split the train and test at this point, because if we come up with the idea that we have to use, let's say, k-nearest neighbor or random forest, you can use the whole data set to train your model based on the k-nearest neighbor or random forest, that is anyone that is better, and apply it on, for example, one of your emails, right? That's the case. You don't need to split it anywhere. The split process is only for evaluating the model and see like which method should you pick. After you pick the method, you pick the right method like k-nearest neighbor or random forest, what you need to do is you can then retrain your model on the whole data, so you don't need to split it anymore, and using that method, and then you can apply it on some new data. Now, anyway, we're just going to skip that point. I mean, at this point, let's say that, okay, we have this model trained in this part. I'm not going to train it on the whole data set. It's going to take a long time probably. But now, in the next part, we just want to do this on one of our real emails. Now, as you can go through this lab work step by step and see what it's explaining to you. If inside the week 6 material in the spam model, there's a function called, there's a file called sample. If you open it up, you can copy and paste the text of any of your emails here. Only the text, just exclude the table or the images or figures and anything you have, and then just put the text here. I put one of my spam emails here as an example. It's a short one, and then save it as the sample.txt. And then if you go here back to the code, open the spam script.r. It's a script that I wrote, which will go through that sample.txt file and will automatically measure all of those frequencies in the spam data set, all of the frequency of those words, the frequency of the punctuations, and the data is going to be ready to be fed into the classifier so that you can see whether this email, this sample.txt, is spam or not a spam. Now, all right, so you can just run this line of code. I mean, after you put your data there, just run this whole line of this whole script, this spam script.r, and after you run it, you're going to get this latest variable here, vector, is called all features. So all features is going to be like, you can see like 57 numbers, and these 57 numbers are the frequencies, different frequencies, or are the features that you have to feed into the classifier, right? If you remember, if you go back to this week 6 material, oops, we have it here, in the spam model, these spam-based headers, if you remember, there's like 57 features here, and which are the features inside this spam-based raw file. These columns, these are the features. There's like 57 of them, remember? There's like, see, we have like 57 features, and then the last one is either spam or non-spam. Now, this script that, if you run the script here, this spam script here, you can go through all of the details. I mean, it's just like I put some comments so that it's going to be understandable. You can exactly understand what every line of code is doing, and you can, I mean, I think it has some like new codings. I mean, that's the reason why I put this up here, because we didn't go through all of the details in our programming, but here you're going to see like tons of functions. Now, these 57 features are the features that are calculated for this what is it, for this sample.txt file, and we're going to feed this into the model that we've created using the predict function in order to see whether it's considered as spam or not spam. Now, there's just a trick here, something that you have to take into consideration is that whenever you want to feed your model, so let's say the model was was trained on the training data set, right? Now, if you want to feed in any sort of like features into this model, the model only understands these column names. So you have to like create a data frame with these column names, and then assign these values to those column names, and then pass it into the model, because the model understands, for example, column x0, and then even the order doesn't matter here. I mean, if they're like different orders, but you should have these exact same columns, and then when you pass it to the model will automatically will just assign those columns to every of these variables which have the same header names. And in other words, it's going to like assign every corresponding feature here to the feature that has the same header here, to the features in the model. Now, in other words, well, here all features is this vector. It's a one-dimensional vector. It's not a data frame. It doesn't have any column names, right? It doesn't have it. It's inside this section. It's not here. This section is like data frames here in this part, right? Now, how should we create a data frame with these column names for it? Well, we can use a slice of the data that we have. Let's just pick like, if we pick like only one row of our data, it's going to be it's going to give us a data frame with these column names. See, for example, I'm going to call a temp, or let's say what should I call it? Sample. Let's call it. Well, we have the sample file, but let's call it the temp. So temp is going to be, let's say, the spam data of, only pick the first row. Okay, let's see. Let's look at it. All right, here temp becomes becomes a data frame. See, you can see I have one object. If you click on it, it's one row with 58 variables, right? Beautiful. So now we have these column names here. Now we can copy this all features vector into this temp. So this temp, well, before doing that, we have to get rid of the last column, because here this last column was spam or non-spam, and we don't have this in all features, right? This is like the 58th column, but we only have 57 columns here. So I'm just going to remove the last column of temp. So temp is going to be remove the last one, right? The last column. Oops, I'm sorry. Not the last column. Not -1 means we get rid of the first column. So we know that this temp has 58 variables, so we can just remove column 58. See, if you run this, what happened that is temp became 57 variables, and it just removed the last column, which was spam and non-spam. Anyway, now we can assign all features to temp. See if it works or not. Well, it didn't, right? Let me see. Okay, let's see what temp is here again. Temp is, one more time. Let's do this one more time. Temp is spam data of 1, and then we can remove the last column again, and let's say if temp is the data.frame of what? Of all features. See if this works or not. It really doesn't. Okay, so it's not going to copy those values inside the temp. Now, okay. Oh, I think I made a mistake here. So temp is spam data 1. One more time. Remove 58, and then let's say, okay. Oh, I'm sorry. I think I made a mistake here. Now the first row is gonna be all features. See if this works or not. Yes, it does. All right, cool. Yeah. So you just got confused a little bit here, but anyway, this is how it works. Okay. So my mistake. Let's go back to this column row here. Now, okay. I'm just going to write the same code that I wrote. So temp is going to be like, we're going to pick a slice, we're going to pick like one row of the spam data, okay, like just one with all of the columns. And then if you're like, this is going to be the temp here. So we're creating the same data frame, see, with the same column names that we wanted. And then we just have to remove the last column. So spam data, oops, temp. Temp is going to be the temp of remove the last column, 58. Now if you look into temp, it's going to be looking like, okay, with 57 columns. Now we have to assign temp, but only the first column, not the whole thing. I was, as a mistake, I was replacing the whole temp data frame with a one vector, with a one-dimensional vector, which was all trend features. But only the first column, which has only one column, but it's not going to change the column. I'm sorry, with only one row, the first row, not changing the columns. It's going to be all features of this. If you run this, let's look at temp. Here it is. What it happened is that it replaced all of the features, and it plugged in all of the features that we all features that we calculated from the sample.txt file. Remember, these were the numbers for all features. See, if you look at all features, these are the numbers, right? Like the latest one is 8. So we just plugged it into this data frame with these columns. Now this temp data is ready to get plugged in into the model. So for example, let's predict using the model. And what is the data? The data is temp, right? Let's see if it works or not. And here it is. So we actually plugged in the temp row, which is the which is a data frame, or which is all of the features that we had for one single email, and we plug it into the model, and we find this class as a 0, which means not spam. Well, it made a mistake right here, right? It's because probably, well, you can try like other emails, longer emails with more words. The sample.txt file that I picked here is very small. It doesn't really have many words, and probably it was kind of like impossible for this model to distinguish it from a spam email. Now the output is 0. This level 0 and 1, it means like this model, or the output of this prediction is like categories of 0 and 1. But this is what you have to look at. This is the 0 means that it's class 0. If you want to get rid of these levels, well, you can just add a as dot character before the predict. So it's gonna give you, for example, just 0, the class 0. Okay. All right, guys. Please, you can plug in more emails. Just copy and paste the text of some of your spam emails into the sample.txt. Like do so for like bigger emails, maybe with more words and more frequency of words, and then just run this code and do the same process and see whether it's going to be considered as spam or not spam. All right, guys. Good luck, and hope you have a great rest of your weekend. Please let me know if you have any questions. I'm going to see you guys hopefully on Thursday. It's going to be our last session for the final presentations. Good luck, guys. Bye-bye.